Alright, in this video I'm going to be going over some things in Inventor, some tips that can make things a bit easier and more accessible. So first thing is that inputs in Inventor can be used as expressions. So say for example we have two lines here and we want to draw another line directly in the middle. Now we have a dimension here and a dimension here, and you could probably do the math to find out the middle in your head, but if we were to give this a dimension, we could let Inventor do the math for us. So if I have a dimension here, I can click this dimension to reference that, hit a minus sign, subtract that dimension, divide by 2, and we have our line directly in the middle, referencing the two dimensions. And the benefit of that is we can change our dimensions and our line still stays directly in the middle. But then say this dimension didn't exist and we didn't know how far away that was, and we instead had a dimension from this side. Well, that's easy too, because what Inventor has driven dimensions, which are already defined by existing dimensions but can still be used as a reference. So if I do this, reference this dimension, divide by 2, and it'll still stay in the middle. Okay, so there's that. Next example. Alright, say we want a couple sets of holes. Like this hole and this hole are going to be the same. This hole and this hole are going to be the same. We can go to the hole command, and we can see right away that Inventor tries to pick up all the centers for the same hole. Now, some people would go back to our sketch, delete one set of holes, make the holes, start another sketch with these other 2 points and make the holes there. But if you want to exclude a set, all you have to do is hold down the control key, exclude the centers you want, hit OK. The sketch will disappear, but if you want that back, hit visibility, that's not the right one, hit visibility, go back to the hole again, and use the centers to make a different hole. And the benefit of that is all the centers of the holes are all in the same sketch, which is more easily accessible. But also notice that these points in relation to this corner are the exact same, have the exact same dimensions as these set of holes from this corner. So basically, if you can see this, there's rotational symmetry about the center. And you can make this even easier if we delete this, draw a line from corner to corner, grab a center point, grab an axis, and a circular pattern, to do it like that. And the benefit of doing it this way is that now this sketch, compared to what it was before, has only half of the dimensions, which is a lot less time consuming. So moving on to some tips for assemblies. Now when you're working with assemblies, generally you're going to be constraining a lot. The constrain button is here. It's nice, conveniently located. But if you don't want to be moving your mouse from the constrain button to your parts every time you need it, you can just use the hotkey C. And when you are constraining, generally you want to be, I guess, minimizing the time you spend panning around, rotating your view, that kind of stuff. And that can be minimized knowing that Inventor always zooms in about the cursor. So say I wanted to constrain this part to this part. I can move my mouse over this part to zoom into it, grab the axis, zoom out, move my mouse over this part to find that, constrain it there, and we have it. So knowing this can help you reduce the time you spend panning around and rotating. So now let's take a look at these 4 parts right here. So all these are supposed to be sort of sandwiched in between these 2 plates right here. So say I grab this face here, rotate around, grab this face here, apply. I can do that, and I can rotate back, grab this face, rotate back, find this face here. But since all these parts are going to be the same height, I can just use a flush command and it achieves the same effect. And the benefit of that is I only had to rotate my view when constraining this rather than rotating it constraining all 4. Alright, so now let's take a look at this. So say this bolt here is supposed to go on the top of that, and this bolt here is supposed to go on the bottom of that. So I guess the first step is to get the center axis there. Now what I have to do is I have to pick up the bottom flat face of this bolt and constrain it to the top flat face of this little stand-up, I guess. So I can pick up this face, rotate around, and pick up that. But another way you can do it is by rotating the part itself rather than the entire view. So to do that, you have to enable free rotating, which overrides all the constraints that are applied to a part for just temporarily. So the hotkey for that is G. So if I rotate this, just the part, overriding the constraints temporarily, I can gain better access to that face, apply it there, and the constraints kick back in once I have applied the constraint. And now say I needed these to appear multiple times within this assembly. I could go to place components, find those components, and place them again. But if I just select them, copy, and paste, I can do it like that. And the benefit of this is all the constraints that exist exclusively between these 2 parts will get carried over as well. So that saves a lot of time with assemblies. Alright, so now for a few tips regarding drawings. So when you're in drawings, generally you're going to want to be annotating. So say for example we have this part here and we want to dimension it with respect to this corner right here. So general dimensions are right here, so I can take that, grab the features I need, and dimension them like that and like that. And that works, but this could be made a lot quicker knowing what other dimension options are available. So let's delete this for a second. So for example, we have a baseline here, which takes every feature you want and references it to the same baseline. So if I click continue, create, that's a lot faster. I can do the same thing with respect to the top, and we can do it like that. Find out how big this is, find out how big the hole is, and that's a lot quicker. Or we could do it in an entirely different way. We could get rid of these, and what we can do instead is use a hole table. So what a hole table does, you pick a part, you define your origin, pick all the holes you want to reference, create it, and what the hole table gives you is an XY position for the center of each hole labeled, indicated, as well as the diameter of that hole. So yeah, those are just a few little tips that help with making stuff easier and more accessible. And that's about all I have. So thanks for watching.